Welcome back, statistics scholars. Today we're going to learn how to use PSPP to do a dependent samples t-test. There are some synonyms for the dependent samples t-test. It's often called the related samples t-test or the paired samples t-test, but it all means the same thing. We're going to have two different groups, but they're related groups. For example, comparing husbands to their very own wives, maybe in terms of housework, or comparing an older sibling to a younger sibling, maybe let's say in terms of academic achievement or GPA. That's the whole idea behind a paired, related, or dependent samples t-test. As a reminder, PSPP is laid out a whole lot like Excel, if you're familiar with that program, with the different variables, the way that people can be different along the columns, and the different individuals you're going to assess are the rows. Person 1 had a height of 78 and a weight of 156. Person 3 had a height of 80 inches and a weight of 160. Right? And up to this point, we've done a lot of analyzing, and we're going to analyze again today. So to do an paired or related samples t-test, you're going to go to PSPP and click Analyze. Then after you've clicked Analyze, you're going to choose Compare Means, because that's what we're going to do. We're going to compare, we're going to look to see if the average difference between the pairs, like the difference between an older sibling's GPA and a younger sibling's GPA, where you actually recruit sibling pairs, you actually have an older sibling with a younger sibling, right? We're actually going to recruit those individuals. So we're going to do what's called a paired samples t-test. That's what it's called in PSPP. So you'll click Compare Means, and then you'll click Paired Samples t-test. Now here is what pops up on my end, because I'm looking at my student data set. So I might in my data set look at the number of units that students have, right? I might explore that. So I might look to see if at the beginning of the semester, students have more or less units compared to now. I suspect maybe that units go down over time as some students choose to drop their classes. So I look at this pop-up window, and then I find the two units variables. The first one would be regular old units, and once again you can right click. I taught you how to do that in the last video. You can right click to make the variable names a little easier to look at, right? So I right clicked and I changed the long label to just the variable name. So I find units, and I use this thing to toggle over variable 1, and then I find units 2, and I use this little arrow to toggle over units 2, and now I have under variable 1 how many units people had at the beginning of the semester, and then under units 2, I have how many units people have now. And so you're going to have you're looking at two columns of data. Because it's a paired samples t-test, what you're going to be looking at is a column of data where person 1 had a particular number of units, and then person 1 had a different number of units. So you're comparing the two columns for this same person. Units 1 and units 2, those two different variables in PSPP. And then, so now for each person, I'm going to be comparing how many units they had at the beginning of the semester versus how many units they had now. Because one of the paired samples t-test approaches is a repeated measures. If I measure the same person twice, that is in fact a paired samples t-test, because I'm going to have to pair your score up with at time 1 with your score at time 2. So repeated measures is an example of a paired samples t-test, synonyms for which also include dependent samples t-test or a related samples t-test. So I'm going to click the two unit variables and pull them over, and this is the output that you will see. So here I have the mean number of units for the beginning and the mean number of units for the end. And of course, in this particular example, in this data set that I have, we have a t statistic, an average difference between the pairs. The actual average difference was 0.84. That was the reduction. From time 1 to time 2, there was an almost full unit deduction from time 1 to time 2, at least in this data set that I have here from a previous semester in my class. And then the t statistic was 16.95, so a very significant, a statistically significant t statistic. And here we have that p-value right here. That significant two-tailed is the p-value, and that has 0.000. It's not actually 0.000. It's probably just 0.000000001 or something like that. But PSPP rounds to 3 places. So what it tells you is that the p-value is essentially 0. It's so small. There's such a small probability that we saw these data due to chance that the p-value is essentially 0. There's almost no probability at all that we saw these data due to chance. There is a real reduction in units from time 1 to time 2. And as you can see, our D bar, for those who've been following my conceptual lectures, the average difference between the pairs between time 1 and time 2 was 0.84, so that kind of reduction, that reduction in units from time 1 to time 2. And then for 55 degrees of freedom, because again, the degrees of freedom for a dependent samples t-test is n-1. Our output shows us that we had 56 people. So n-1 would be 55 as our degrees of freedom. That t-statistic that we've just had PSPP calculate for us is 16.95. So these are very far apart, right? 16.95 standard errors apart with a p very, very small. And then I also have the confidence interval here. And remember, this confidence interval is the confidence interval around this mean difference of 0.84, this average difference between pairs. And this is essentially saying I'm 95% confident that the real difference in units for the beginning of the semester compared to the end of the semester for the population, because again, I only have a sample of 56, the real average reduction in the population is somewhere between 0.74 and 0.94. So not 0, right? We can effectively reject 0. And we knew that from the t-statistic too. We reject the null hypothesis and we conclude that there is a statistically significant reduction in units from time 1 to time 2. And in fact, we're very confident, 95% confident, that the true change is somewhere between 0.74 units and 0.94 units. So somewhere right around there. We could also calculate a Cohen's d using these data, because this here is the D bar, and then here is the standard deviation of the difference scores. So to get Cohen's d, we would simply take 0.84 and divide by 0.37, and that would give us our Cohen's d. And in this case, eyeballing it, it's bigger than 2. I think it's bigger than 2. So that's a very large effect. Looks like there's a very large effect for at least my students in a previous semester, a pretty hefty reduction in units from time 1 to time 2. Thanks for watching, and this is in fact how you conduct a dependent samples t-test in PSPP. Before I sign off, actually, I'm going to run through some real data, so 1 second. All right. So as promised, I want to actually run through a paired samples t-test live and in person in PSPP, and I'm using a sample data set from a set of college students from 2014, so from a few years ago. And what I'm going to be doing is I'm going to be comparing each student's English and math scores on a standardized assessment, because I suspect they're not going to be the same. I think at this particular college, one of those is going to be significantly higher than the other. So again, this is a paired samples approach because I'm looking for within one person, right, a whole set of people, is their, let's say, English score higher than their math score? But I'm just curious if they're different. I would be interested to discover that the English is higher. I would also be interested to discover that the math was higher. But I do think there's a disconnect. At the school, I think one of those scores are higher. This might interest me because I might want to know where to funnel tutoring dollars, right? Where is there a deficit at this school such that students are systematically doing not as well in one of these areas? So I'm going to compare everybody's average English score to their very own, well, not their average, but their own. I'm going to compare each person's individual English score to their individual math score to do this paired samples t-test to see if there's a difference between these two sets of scores, everybody's English scores and then everybody's math scores. But again, they're paired up. Let's go ahead and look at the data. So here we see everyone's English score here in this column. And here we see everyone's math score in this column. So what PSPP is going to do is it's going to calculate the difference between the English score and the math score, and then get a set of different scores, and then do that paired samples t-test on that average difference between the pairs. So let's do that. I go to Analyze, Compare Means, Compare Means, go to Paired Samples t-test and left click, and then this is the window that pops up, right? So we're going to grab the English variable and pop it over here with this little, you click on it, left click on it, then you use this little arrow to pop it over there. And then we're going to click on the math variable and we're going to pop it over here. And that lets PSPP know that we're comparing the scores each person has on these two variables. You have some options, right? Like you can change the size of the confidence interval if you want. If you click on options, you can actually tell it, no, I want a 99% confidence interval, or I want a 90% confidence interval. That will change things for you. It's essentially changing your alpha, right? For those watching my conceptual lectures, alpha is, of course, that area of rejection. And if you have an alpha of 5% or 0.05, then your confidence interval is going to be at 95%. But you can change it. You can choose an alpha of 0.01, which is 1%, and then you'll have a 99% confidence interval, right? But we're not going to do that. We're going to keep it at 95. So then I'm going to click OK. Left click. And then this is the output that you'll see in that separate PSPP output file. Here we can see that there was a 17-point difference in scores between the English and the math scores. That's the average difference between pairs again, with this standard deviation of 9.5. So this is going to be what I call D bar in my class, and this is S sub D in my class as well. So this is the data, the average difference between the pairs, and this is the standard deviation of those different scores. And here we can see the confidence interval does not contain 0. I'm 95% confident that the real difference between math and English scores at this college is between 16.36 and 18.23 points. And look at this enormous t statistic. Oh my gosh, so huge, right? 36.31, and again, the p-value is super, super tiny. There are definitely, English scores are much higher at this college than math scores. Better get some of those tutoring dollars into math. All right, I'm really signing off now. See you next time when we learn how to do ANOVA.